This video tour is designed to introduce Deducer to expert users who may know R pretty well. Um, Deducer is cross-platform and it's cross-console. So in Windows and Linux, you can use Deducer in the regular Windows GUI. You can use it in the terminal. You can also use it in the Java console Jgr, which is what we're going to use it in here on the Mac. And its main goal is to help speed up your analyses by replacing a bunch of for loops and other programming that needs to be done by a couple of mouse clicks. So it's really about making you more efficient as an analyst by automating some of the programming that you have to do. So this is the Jgr console. It's a fairly nice console. We can open it. It has syntax highlighting, so we can, for example, open up this document here, look at it, and we can send it to the console by hitting Command Enter, and we see the results of it there. So it's a fairly nice environment to work in. And let's go ahead and load Deducer, which is just an R package like any other. And we see a couple new menus appear, the Data, Analysis, and Plots menu. And we also see a nice data viewer here, which we can use to edit our data frames, look at the factor levels, edit the factor levels and contrasts and whatnot. As an example dataset, we're going to load in the movies dataset. And we're going to perform one task from each one of these menus. The data menu is for data manipulation. Analysis is for, obviously, analysis. And plot has a very powerful GUI built on top of the ggplot2 package. So let's go ahead and well, first let's take a look at the data set here. So we'll go to the movies data set, and we see the titles, the year. The variables we're going to be interested in is the rating by users on the IMDb website, the votes, and then these R variables, which are the percentage of users who voted who rated this movie 1, 2, 3, 4, all the way up to 10. We're also going to be interested in the Mpaa rating of these movies. So let's go ahead and take a look at the ratings. See do a little frequencies here, and we see that most are not rated. Very few are NC-17 rated. So really, the meat of this variable is going to be in the PG, PG-13, R area. So let's go ahead and do a subset analysis. So we're going to take a subset. We're going to say Mpaa is not going to be equal to nothing, and it's also not going to be equal to NC-17. Go ahead and run that, and we get a new data set, movie sub, which we can then take a look at and see that our subset worked out okay. And it did. These two levels now have no cases. And let's go ahead and look at some descriptives of our outcomes of interest, 12 of them by Mpaa. And we'll also get the median 25th percentiles. Run it, and we get a nicely formatted table of our mean, standard deviations in the PG arena, PG-13, and R. So let's go ahead and do an analysis on that, a k-samples test. And we'll do a Welsh ANOVA and a Kruskal-Wallis test because we may have skewed data. Our outcomes are going to be here, and Mpaa is going to be our factor. We'll also take a look at a plot. And we go ahead and run it. So we can see that almost across the board, highly significant, both in the non-parametric and in the parametric case, except in the cases of R5 and R9. And that also holds up in the Kruskal-Wallis Test. R5 and R9 are both non-significant. And we get a nice plot out here, which we'll make big. That shows us that, for example, votes is very highly skewed, and the R's are sort of semi-continuous. You can only take a discrete number of values. And that even though ratings is very significant, in a qualitative basis, the medians and means are not particularly far apart. So we could have done all of this in regular old R. We could have written some for loops around the Kruskal test and the one-way test. We could have even written code to format that all into a nice table like we see right here. But we could have also done it in an assembly line. The point of this is that we can do it more quickly and more efficiently and get on to the points that really matter in examining our data if we do it through a graphical user interface. Not everything is great for a graphical user interface. The more complicated an analysis, sometimes the command line is the simplest way to do it. But I think that there definitely is a place for graphical user interface in the professional data analyst toolbox. So again, this is just sort of a very short introduction. There's a lot of different data manipulation functions that you can do. There's a lot of different analysis functions. And the plot builder we haven't even touched on. We'll touch on that in future tutorials. So there's actually a lot in here, and it's also highly extensible. For example, there's some additional functions in the Deducer extras package available on CRAN. And this is an add-on package written entirely in R, and it adds in dialogues for a number of other types of analyses and quantities of interest. So it's an extensible system. It's cross-platform, cross-console. You can use it wherever you happen to be programming, and the goal is to make you a more efficient analyst.